The purpose of this video is to discuss rationalizing the denominator when dealing with square roots. Rationalizing the denominator is the process of removing the square root from the bottom of the fraction. This is a last-ditch effort. When simplifying an expression, this is to be done after you can't simplify, after you can't multiply, and after there's no more division to be done. But you look at a problem and there's still a square root in the denominator. This should only be used when a square root cannot be simplified and is in the bottom of a fraction. Why do we rationalize? We rationalize so that all the answers are written in the same format. Having a rational denominator, so let's talk about this for a second. A rational number, our numbers can be written as decimals or, repeating decimals, terminating decimals. These are your nice decimals. Things like the square root of 2, square root of 5, square root of anything not real are referred to as irrational numbers. So when we have a square root in the bottom, this is irrational, and we don't like irrational numbers in the bottom of fractions. So by rationalizing them, we make sure they're all in the same format. We do this so that we can easily see when to combine like terms, and you'll deal with more of that in Algebra 2. And before calculators, calculations were all done by hand. This idea of rationalizing made calculations easier. So I want to deal with first, should it be rationalized? I have several problems down below in categories yes and no. You rationalize when nothing else can be done. So looking at the first problem. I'm going to simplify this. I know that the fraction 2 over 6 is the same as 1/3. Radical. I can split the square root of the radical. Square root of 1 is 1. Square root of 3, well, it has the square root still in the bottom, so this one does need to be rationalized. I'm going to do the same thing here. Square root of 4 over the square root of 5. While the fraction 4 over 5 can't be reduced, square root of 4 is 2. Square root of 5 is the square root of 5. So this fraction will need to be rationalized. Square root of 8. Well, the square root of 8, if I break it down, gives me 2 square root 2. There's no denominator, so no, that one does not need to be rationalized. Looking at the next example, 2 square root 3. 2 can't be simplified, square root of 3 can't be simplified. So this fraction does need to be rationalized. The next one, this can be broken down into the square root of 4 and the square root of 25, which is 2 over 5. Both of those numbers are rational. There's a rational in the denominator, so no, that one does not need to be rationalized. These two things multiplied together, square root of 9 is 3, times the square root of 2. Notice there is no denominator, so this idea of rationalizing does not apply. Simplifying, the square root of 2 and the square root of 32, I'm going to simplify the fraction and call it, let's see, 2 over 32 is the same as 1 over 16. Square root of 1 is 1, square root of 16 is 4. So really when I do all of the math and have simplified it all the way down, I get 1/4. Notice that 4 is a rational number, it's not a square root, so this process does not need to occur. And then for the last one, square root of 2 does not simplify, but the square root of 9 gives me 3. So again, there is no square root in the bottom. I do not want you to think that the process I'm about to show you needs to happen all of the time. This is, again, a last-ditch effort. When you realize you can't simplify, multiply, or divide, and you look at a problem and you still have the square root on the bottom, then you will go through the process I'm about to show you. Couple of things to understand. What is x times 1? Well, it's x. Anything times 1 is itself. What does 8 over 8 equal? 1. What does 3x squared over 3x squared equal? 1. Square root of 2 over the square root of 2? 1. You take any number and divide it by itself, you're going to get 1. We're going to use that idea here. All right, let's go ahead and rationalize. First thing, make sure that the problem needs to be rationalized. Do you have an irrational number in the bottom? Yes. If you need to, if you have one of those big square roots, you'd split it into two small, but that is not applicable for this problem. Multiply by magic 1. I want to rearrange this so that there's no longer an irrational number on the bottom. We set up above that any number times itself is 1. I'm going to multiply by the square root of 2 over the square root of 2 because the square root of 2 is what I need to get rid of. This is essentially just equal to 1, so I'm not changing the value, I'm changing how it looks. When we multiply fractions, we multiply tops times the tops. I get 3 times the square root of 2. Then I multiply bottoms and bottoms. Square root of 2 times the square root of 2 is 4. I'm going to continue to simplify. Simplify top and bottom of the fraction. 3 over 2 do not simplify. There is my answer. Here's another one. Make sure you need to rationalize. Because the square root of 10 is an irrational number, this process does need to occur. Here, I do not have one large, so it's not applicable. Multiply by the magic 1. Because the square root of 10 is what I want to get rid of, if I multiply both the top and the bottom, multiply by the square root of 10, this ends up equaling 5 square root 10 over the square root of 100. Well, the square root of 100 is 10. Check your fourth step, simplify top and bottom. If you notice, 5 over 10 is a fraction that can simplify. 1/2, and we still have the square root of 10. We know that we don't need ones in front, so don't feel obligated to write it. Let's do some practice. Simplify. I'm looking at problem A. There's an irrational number on the bottom, so this process needs to occur. Multiply both top and bottom. Square root of 6 does not simplify. The square root of 9 simplifies to 3. There's my answer. I'm going to keep going. This is an irrational number, so the process needs to happen. Multiply by the denominator. Multiply the tops. Multiply the bottoms. 6 square root 5. The square root of 25 reduces to 5. I'm going to break this into its two small pieces. Square root of 4 is 2. Square root of 3. I've simplified the fraction, but it still has an irrational number in the bottom. Multiply by magic 1, meaning the number on the bottom. 2 square root 3 over the square root of 9. 2 square root 3 over 3. Looking at 2 and 3, they do not reduce anymore. And the 3, this is a normal 3, this is a square root, so they can't combine. I'm just going to keep going so you guys can see me do a couple. The square root of 4 is 2. Now I understand that 2 goes into 6, but this is the square root of 6, so it doesn't simplify any further. And here's the last one. Oops. If you look at all of my answers, the numbers in the bottom are not numbers within a square root. They are rational, nice numbers. So I know that I've at least done something right. I'm going to try a couple more, and I refer to these as double simplify. There are multiple things that are going to have to happen. For the first problem, I'm going to start by splitting the square root. I know that the square root of 8 can reduce. It reduces to 2 square root 2. I've done all the math correctly, but there's still a square root in the bottom, so the number that needs to be multiplied by is only that square root. The tops give me the square root of 10. This 2 here is still there, but when I multiply the square roots, I get the square root of 4, and I'm going to keep going. 2 square root of 4 is another 2, so I have the square root of 10 over 4. This problem is also similar. Let's see, the square root of 12 reduces. So it gives me 2 square root 3. So when I go to do this problem, I'm going to multiply both the top and the bottom by that square root. It gives me the square root of 15. That 2 stays put. These two things give me the square root of 9. Almost done. 2 times 3, the square root of 9 is 3. I get the square root of 15 over 6. Done. Looks like I ran out of room for letter C. The square root of 6 doesn't break down into any pairs, so I'm going to go ahead and just start rationalizing. I end up with 8 square root 6. If you guys notice a pattern that's been happening, when you take a number times itself, the square root times the square root, look what it ultimately gave you. The square root times the square root ultimately gave me that 3. I'm going to go ahead and start using that pattern that if I know the square root of 6 times the square root of 6 gives me the square root of 36, those square roots end up essentially canceling, and I end up with a 6. Looking at fractions, 8 over 6 reduces. Let's see, the fraction 8 over 6 reduces to 4/3, but I still have the square root there. If you want to, grab a calculator, type in the original, you'll get a decimal. Type in the answer, you should get the exact same decimal. I have 2 more to do. 10 is a normal number, it's not breaking down. Square root of 2 can't break down, but because that's irrational, I'm going to go ahead and multiply by the magic 1, which is the number on top and bottom. 10 square root 2 over, I know that the square root of 2 times the square root of 2 gives me 4, and the square root of 4 is 2. Looking at the fractions, 10 divided by 2 is 5, and I still have the square root of 2. Last one. The square root of 3 times the square root of 3 gives me the square root of 9, which is 3. 4/3 doesn't reduce, and the square root of 3 is in the 3. Now I realize that that was quick. I'm hoping that with a lot of examples, you can at least give your homework a try, and there will be more opportunities to ask questions in class. Thank you, and I apologize for my raspy voice.